So, aye, this on the SQA website. You can actually get access to this if you really want to go and have a look at it. But there's the breakdown of the marks that they got. So they got 6 for the research method, which is the maximum, 4 for the processed information, which is the maximum, 8 for knowledge and understanding, 4 for analysis, 2 for conclusions, which is the maximum, and then communicating information, is it in a correct order, is the structure good, and they get 4. Basically, according to the SQA, you start with 4 out of 30, right? You're automatically given communicating information. You then have to do something ridiculous to then get the 4 marks taken off you. So you kind of start with 4 marks, and that just means, are you using geographical terms? Have you kind of explained the processes, that kind of thing? Is it in a reasonable order? Can I read it? And does it make sense to me when I read it? Yeah? And that gets you 4 marks. You essentially start with 4. Alright? So we'll go through this. Make sure you're kind of looking at the processed information as well. Make sure you look at that sheet, because sometimes they don't get the marks because it's just a direct lift from the processed information. You need to actually add value to it by saying higher than, more than, less than, double, triple. Yeah? You need to add value to your processed information. So here it is. They've got their question: does the Glen Rosa River conform to the 3-stage model of a river? Very similar question to what you have. Yeah, some of you have basically the same question. So they've got a name. What they're trying to do, they're trying to say what it is. They've got their null hypothesis, their alternative hypothesis. Yep, and they go into their background information. So they talk about where the river is and so on. They actually get a mark on this page, right? There, a processed information mark. Because if you look at graph 2, right, they can read from that the distance of the river is 8.6 kilometers. Alright, and they've lifted that from it. Alright, so they actually get 1 mark for using the process information for saying how long the river is and actually having that information on a graph in the processed information. Alright, so that is where they get their first mark. Yeah. They then move on to their collection techniques, or their GMTs. They've got primary research here. I don't think they get any marks when it says primary research, alright, because it's just more a list of what the information they try to find. Do we see that? So it says collection for each stage of the river: upper course, middle course, and lower course. For each area, the width, bank, full width, depth, wetted perimeter, velocity gradient, bed load size, and bed load shape. So actually, they're not really saying anything, they're just listing all of the information they found out. So they don't get any marks in that first paragraph of that page. Yeah, where they pick up the marks, yeah, is here. Yeah, so bed, load, shape, and size. So pebble analysis, right? And they get, see what it says at the end of depth. So a total of 30 rocks were collected from across the transect of each of the river measured. This allowed the bed load size to be taken using a meter stick, measuring length, breadth, and depth. Yeah. What they've done there is they've said exactly what they did and how they did it. Right. Here's what we did. We picked up 30 pebbles. We then measured them using a meter stick. What did we measure? The length, the width, and the depth of the pebbles. 1 mark, and it's a technique mark, so that's why that T's there. Alright. The next mark they get is at the end of that paragraph. They're going to add a wee bit onto that by saying the bed load shape. So they've talked about size, they're now going to talk about shape. Yeah, the bed load shape was taken by referring to the powers index. Yeah, that's the card we had, from very, very angular to well rounded. Yeah, to place the rocks, referring to the powers index, to place the rocks in the category of 1 to 6 based on their roundness. Second mark. Alright, so that's where you're picking up the second mark there. So for bed, load, shape, and size, they're picking up 2 marks. And what they're saying isn't that complicated. Yeah, they're just explaining exactly what they did and what they use to help them do it. So, moving on to the velocity paragraph then. Yeah, they get a mark at minute where it says the speed at which the water flows was taken by measuring velocity with a flow meter. So they've done a slightly different way from us. They used a tool called a flow meter. We used the tangerine and the speed distance time measurement. Alright. Yeah, the flow meter was placed under the water for a minute. So what they do, they place it under the water for a minute and that records the speed. Slightly easier than we done it, but not as much fun. Why do they do this? So that an accurate reading could be taken. Counts were recorded there. That's it. Counts? Currents? Looks quite rude, that word, doesn't it? Eh? Yeah. I mean, we'll go with counts. Were recorded by the meter, and the difference in counts can later be used to, but they get a mark there. Yeah, for saying that they've done it several times, and that they're aware of differences and how they're going to use these. All right. So on that page there, they're actually getting 4 marks. So they've got 4 out of 6 research method marks already. Are we following? Anybody got any questions about that then? No? Everybody quite happy? Everybody thinking a wee bit more confident about your own research methods and writing them up? Good. Right. Now, here's where they're slightly different, and this is what I was talking to Steph about yesterday. They've included 3 research methods, right? You only get credit for 2, right? So although when they talk about the gradient, they get 2 marks for it by talking about how the distance and the used ranging poles, all right? And it was measured in degrees using a chronometer and all that, right? That now gives them 6 marks for the research methods, right? But because they've used 3 techniques, only 2 of them can be counted. So although there is 6 ticks, they're actually only sitting at 4 marks. So you have to weigh up when you do your assignment, do I have enough time to do 3? And then you can try and pick up the marks. You know, if you get 2 for 2 of them and 1 for the other, you'll get 4, rather than if you just only write 2. So you've got to weigh up, do I have time to do that, or am I just going to try and perfect 2 research methods? Where they get the rest of the marks to make up the 6 is for their evaluations. So they talk about the strengths of doing these type of techniques, that they use 9 sites, yeah, 30 measurements of bed load size, so you can get reliability, so you're not just picking one and it's, yeah. And they get a mark for talking about the weaknesses. Alright, one of the big weaknesses is, for pebble shape analysis, is people's perception of roundness may vary. Human error, human opinion, it differs. Yeah, so depending on who's looking at the rock, they might say that's well rounded, they went, it's not, it's maybe sub rounded. So that is where they pick up the last 2 marks for their evaluation. And that's why I've said to you sometimes to write about the issues you had gathering that information. Because as you evaluating that, although I found this information out and this, I've done it, you know, here is an issue with it, and I'm aware of this. I'm aware of this issue, rather than thinking, oh, we done it and it was all perfect. All right. So moving on then to the results section. This is the section I think that most people here are finding the most difficult to put together. I think we've all got the information, but it's actually putting that information together I think we're finding most difficult. All right. So again, they've set this out by talking about gradient, what results they've got for gradient, and then they move on to the next bit, velocity, width, depth. All right. So they've set this out kind of section by section. Yeah. The way that the other exemplars I showed you have set themselves out. So they get a KU mark, so a knowledge and understanding mark, where they talk about the gradient of a river is a measure of the steepness of its slope in the upper course of the river. The gradient is much steeper than it is normally on mountainous land. This means the river is fast flowing with an increased meadow size. Consequently, more vertical erosion occurs. So they actually get the mark for talking about vertical erosion here. Right? The knowledge they're adding to this is that vertical erosion occurs. So they get the KU mark there. Now, that's nothing spectacular that they wrote there, but it is then demonstrate that they have knowledge and understanding of the area, and they're aware that in upper course, more vertical erosion happens. Yeah. The second KU mark they get is that they talk about weathering of the valley loosens debris which collapses into the river, where it's transported downstream, hence a steeper gradient. So they're given another reason for the steeper gradient, and they're talking about weathering, which we can link into freeze for. Yeah, making these steep scree slopes. We following so far? I know this isn't the most exciting lesson, folks, but it will help you understand where the SQA are given marks and actually where you can pick up marks that maybe you've not thought about before, things you can add into it. Alright, they get another KU mark at the end of that paragraph. Yeah, for saying in the lower course, much of the vertical erosion has already occurred, so mainly lateral erosion takes place through the process of helicoidal flow. Right, they get the mark for mentioning this thing called helicoidal flow, and that just means that the water kind of flows in a spiral way. Alright, so it's almost like a drill turning, and as it moves through the kind of river channel, it's eroding because it's constantly spinning. Alright, and that's all helicoidal flow is. Yeah, and they get a mark for saying that it used to be vertical erosion up here. Down in this part of the river, it is now lateral erosion because of this, and they get the mark there. They get a processed information mark for referring to figure 1, I think. Yeah, it's shown that there is a steeper slope from sites 1 to 4. Keyword being steeper, they're adding value to it. Yeah. And there is a more gradual slope from sites 5 to 9. Yeah. So they're picking it up for saying it is steeper. They're adding value to it. Alright. They get the second process information mark, the third one of the whole assessment, but the second one in this paragraph, where it says site 1 upper course has a steeper gradient of 6 in comparison to site 9 lower course with a gradient of only 1. Alright. So you'll be able to find that on the graphs. So what they're doing is they're taking information from the graphs, adding value to saying this is steeper than, you know, here you'll find it this, but here you'll find it this. Yeah? Any questions so far? No? Everybody quite happy then? So on that kind of page alone so far, they're sitting at 5 marks. Right. The top of this page then, right, still talks about gradient, so it's coming from the next page. This might be where it gets a wee bit confusing. I'm sure like page 27, isn't it, where it was to be, but so we're looking for the page that has sediment as the heading. Alright. Right. They get an analysis mark at the top of that sort of paragraph, right? And this is kind of where it differs between KU, so this is really important that we're paying attention to this, folks, right? So it says, this gradient is representative of the mountainous land at the source of the river, where the height was approximately 400 centimetres. The short distance of the river means that there is a sharper decline as more erosion takes place in order for the river to reach sea level. Alright? So they get this for analysing that the short distance of the river means more erosion, yeah, because by the time it reaches the sea, it's got to be at sea level. So because of the shorter distance, they can sort of say that more erosion takes place to get that to hit sea level. Alright? And that's actually where they get an analysis mark. They're taking their knowledge of erosion, gradient, and they're kind of putting it together to say that because it is steeper and shorter, more erosion is taking place. Any questions about that mark then? So, the next one they get is in the sediment section, and it's a KU mark, and it says the bed load size generally decreases down a river at the upper course. Bed load is larger and more angular, whereas at the lower course the bed load is smaller and more rounded. KU. They could have picked that information up from their model that they've got, yeah, or from their knowledge in class to say this is how a typical river looks. The next mark they get is another KU. It says this is due to abrasion, the erosion of the river bottom, yeah, and river bank by material carried by the river. So they've said it's due to abrasion, they've explained abrasion, and they've got the KU mark for it. Yeah. They get another mark. We're going on to explain the transportation process of traction. Yeah. And more rounded through, so it becomes smaller because of abrasion, becomes more rounded because of traction, and then it goes and explains that the material is rolled along the riverbed. Yeah? Following so far? You all super excited by this? This is what it's like for me marking all of yours. Right? So if you don't like me, make sure you hand it in, and I have to mark it. If you're feeling super generous, don't hand it in, don't pass higher, and I don't have to mark it. Okay? Nice. So the next mark they get is at the end of that paragraph, again, because they go on to explain one of the processes, and in this case it is attrition. Alright? Pay attention, Morgan? Sure? Are you typing the marks into your phone? No? Thought you were there. So, what have they got on that page? So they've got 5 marks on that page. So between 2 pages, they're sitting at 10 marks, plus the 4 the SQA give you, unless you prove to them otherwise. Right, they get a process information mark here. I think they get 2 in this paragraph actually. Yeah, they get 2 process information marks in this paragraph. Right, but they also miss out on 2 marks. Right, because see their bed load pie charts. See how it's got the percentages written on it? Yeah, it's got the actual numbers, the percentages written on it. They don't pick up any marks for just straight lifting them. So actually they had the potential to get 4 marks here because they've just straight lifted from the process information without adding any value to it. They only get 2. Can we see that? Can you see how that kind of works? So if you just direct lift from process information, you're actually missing out on giving yourself some marks. Alright, we'll move on to the next page then. So it's one that starts with, or has velocity as a title. These are printed in the right order, but actually the SQA have put them on the website in the wrong order, so just be careful of that. Alright? So, they get the first mark, a KU mark, here, for explaining hydraulic action. Now, personally, their explanation isn't very good. Hydraulic action, the sheer force of the water. I wouldn't have given the mark for that. I don't think it's good enough at a higher level. But the SQA do. So they've got the mark. So your explanations are going to be much better than that. Right? Because I force you to do it all of the time. And I force you to do it in good detail all the time. Alright? And that's just going to ensure that depending on who marks it, are they actually going to give the mark or not? Because again, it's subjective to the person who's marking it. But we want to ensure that we take as much of that out as possible. Alright? So they get the mark here for explaining hydraulic action. They get the next mark on this page as an analysis mark. Alright? And because they talk about, from here, this could be due to the mixed geology of Glen Rosa, as there are bands of igneous rock such as granite amongst bands of sedimentary rock. The hard igneous rock, therefore, more difficult to erode. So they get an analysis mark there for saying that harder rock is more difficult to erode than softer rock, and linking it into the geology. And I spoke to you about a wee bit about the geology yesterday, of basalt and andesite, and how they're kind of igneous volcanic rocks. They get a second mark on this paragraph for then talking about the softer sedimentary rock, being easy to erode. So they get a mark for saying, here is a geology, hard rock is really resistant, and then they get a mark for saying, and soft rock isn't he? Alright, so although it's kind of stating the obvious, you're actually going to pick up marks for it. Alright, so if you think, oh, that's too simple, include it anyway, because you're picking up marks for it. Right, in the velocity paragraph, they don't get any marks here, but in this velocity paragraph, they pick up a mark for when they talk about at the end of fast flowing water, right? So as a river flows from source to mouth, the velocity will generally stay constant, although may have a slight increase. To me, that doesn't make sense. Alright, they don't get any credit for not making any sense. In the upper course, water flowing through channels would be affected by friction, and this is where they're picking up the mark, because they're going to talk about sharp angular rocks here. Alright, they get the mark for talking about friction essentially slowing the water down. Alright, so as despite the steep gradient, the large angular rocks will prevent fast flowing water. So they're basically saying, I know it's steeper, but actually it's slower because there is so much friction, and that's where they're picking up this TU mark. Any questions so far then? Are we all understanding where we're picking up marks? And you're all understanding that you have all this information, and you know all this information, it's just how you put it together. Steph, you alright? Yeah, you just looked really confused by the bit of paper there. Alright, so on to the next bit. It's the one with conclusion in it. So you'll need to find that one. I think this is roughly where it gets all a wee bit mixed up. Alright, so this links in from, so size is larger and the river banks are smoother at living, the river can move without obstacles, therefore increasing its efficiency. So they get a mark here because it links into the previous one on friction, where it says increased friction slows the river down, but as you go further down the river, the banks get wider, the material in it gets smoother, so actually it improves the river's speed. So that mark is linked to the previous paragraph. Alright. It then continues to say, the results show an increase in velocity as you move from the upper to lower course. Refer to figure 8. So he's telling you, or this person is telling you where to look. Go and look at figure 8, because you'll find at site 2 upper course the velocity was 9.7 meters per second. This continues to increase, adding value to it. Here's what the velocity is. It's continuing to increase. It's proving my point that it's getting faster. To site 6, where velocity was 15.3 meters per second. So they're getting a processed information mark because they have lifted it from this. Alright. Any questions so far? Everybody quite happy? Yeah. They get a second processed information mark. Yeah. It says the water slows and velocity only slightly increases at site 8, 15.9. There is an overall increase in velocity of 10.6. So they say they're getting the mark for here, this overall. So they're taking their process information and they're saying, so when I started looking at it to when I stopped looking at it further down, I actually increased speed by this amount. It's travelling 10 meters a second faster than it was. Alright? So it's the same information, but they've managed to pick up 2 process information marks there. Alright? I think what's that? They're sitting at now 5 process information marks, and the maximum you can get is 4. So they've got full marks for that kind of section. They get an analysis mark here, where it says the Glen Rosa River shows a steady increase in velocity from the upper course to lower course, which is expected. This is due to a reduction in sediment size, allowing water to travel with limited friction, and therefore increasing its speed of travel. Alright, and I get an analysis mark there. And I get an analysis mark at the end of that paragraph for saying there's also increased channel size through the width and depth, yeah, an increased volume of water from surrounding tributaries, and through flow from drainage basin area. So they're getting the mark here for linking in through flow and the tributaries to the increased amount of water, which is linked to the increase in speed, because you've got that larger area not touching the river bank, so the water will go faster. Yeah, following. Everybody quite happy so far. Alright, they get a conclusion mark here. I think that they could possibly get up to like 4 conclusion marks here, but again, the section's only out of 2, so they only get a maximum of 2. But it says the Schum model, figure 9, effectively displays that the characteristics of a model river. Through comparison of results from the Glen Rosa River and the Schum model, it can be concluded whether or not the Glen Rosa River conforms. So they're basically saying we can make a decision here. Alright? Yeah. We've used all this and we can make a decision, and then is this right on that? Figure 2 effect displays an overall decrease in gradient from the mouth to source at the river. The gradient of the Glen Rosa River is steeper through sites 1 to 4, and has a more gradual slope from sites 5 to 9. So look for that page. This is where it gets mixed up. I think they've got this page. What? Is it? And if that again, that's the SQA with a genius quality. But if it's the same, I just put it to the side. Alright. They get a mark here for this statement. Yeah, referring back to figure 9, it is evident that these results conform to that of the model river. So they've said, here is the results I found. We've already mentioned them previously, so it's no new information in the conclusion. And they're saying, from these results, my conclusion is that the gradient matches a model river. Conclusion mark. Alright. They then get a conclusion mark for here, for saying the bedload size decreases from site 1 to 9 due to whatever reasons, yeah, and this is as I expected. So they've concluded that I expected this to happen, and my information proved that I was right to expect that. And they get the last conclusion mark, which says the Glen Rosa River showed a noticeable increase in velocity, although it is only expected to see a slight increase in velocity. This conforms to that of the model river. So again, there's no new information in their conclusion. They're just saying, here's what I found out in the results, and here is my conclusion from that. It does match the model river. Yeah? And then, right into the end, yeah, they've accepted their null hypothesis by writing it here. Glen Rosa does conform to the model river. Ellie, did you just use that to wipe your face? Alright. It's not a napkin. Anybody got any questions about how that's marked then? They've probably not included it. So I think they got 26. So if you talk about width and depth, they briefly talk about it when they talk about lateral erosion and how it gets wider, but they don't specifically go into details on it. So I don't know if they maybe ran out of time, because you only get an hour and a half for this. So you've got all that information. You can end a paragraph on width and depth as well and go on to explain it. but they kind of mention it throughout when we talk about lateral erosion right at the start and vertical erosion with our picking up KU marks. So that's where they kind of mention it there. Any other questions?